Students, today's topic is normal distribution. This is also a continuous probability distribution. Yesterday you have already seen one continuous probability distribution, that is the exponential probability distribution. Today we will see normal distribution. The continuous probability distribution having the probability density function PDF as f of x equals 1 upon sigma root 2 pi e raised to minus x minus mu whole square divided by 2 sigma square, where x lies between minus infinity to infinity, mu lies between minus infinity to infinity, sigma is greater than 0, is known as normal distribution. The mean of a normal distribution is mu and the variance of normal distribution is v. That is, the mean and the variance of a normal distribution is equal to the mean and the variance of the given distribution. Now we have standard normal distribution. Now under standard normal distribution, probability of x lying between a and b is given as 1 upon root 2 pi integration z1 to z2 e raised to minus z square by 2 dz, where z1 is a minus mu by sigma, z2 is b minus mu by sigma. Now, a function phi of z equals 1 upon root 2 pi 0 to z e raised to minus z square by 2 dz represents the area under the standard normal curve from z equals 0 to z. So, this shaded portion gives us the value of phi of z. It is the region covered by this curve from 0 to z. Now, this is called as the standard normal curve. It is symmetric and bell-shaped. Now there are two important results. Minus infinity to infinity f of z dz equals 1. That means the area covered by this curve will be taken as 1. Second thing, minus infinity to 0 or 0 to infinity phi of z dz is 0.5. That is the area of half of this portion. This is minus infinity to 0, this portion, and this is 0 to infinity, this portion. So as this is symmetric curve and the total area is 1, so these two areas will give us 0.5. These results in the equivalent form are, so the consequences of these two results are the following results. Probability of z lying between minus infinity to infinity is 1. Probability of z lying between minus infinity to 0 is 0.5. Probability of z lying between 0 to infinity is 0.5. As I shown here, this 0 to 0 to minus infinity covers half of the curve, so 0.5, and 0 to a plus infinity also cover half of the curve, so that is also 0.5. Probability of z greater than or equals 0 is 0.5. Now probability of z less than z1 is given as 0.5 plus phi of z1. Probability of z greater than z1 is 0.5 minus phi of z1. Probability of z lying between 0 to a is known as phi of a. Probability of z lying between minus a to 0 is also phi of a. Now phi of a can be theoretically calculated as phi of a equals 1 upon root 2 pi 0 to a e raised to minus z square by 2 dz. Here I have taken a as 1.55, so I have put it as 1.55. So phi of 1.55, by using calculator you can calculate this. You will get it as 0.4394. Suppose I want to calculate phi of 2, then it will be 1 upon root 2 pi 0 to 2 e raised to minus z square by 2 dz. Now phi of z can be found from the normal probability table also. Due to symmetry of the standard normal curve, we have these important result. Probability of z lying between minus a to minus b is same as writing probability of z lying between b to a. Probability of z less than or equals a is same as probability of z greater than or equals a. Probability of absolute value of z less than or equals to a is same as writing 2 phi of a. Probability of z less than or equals minus a is same as writing probability of z greater than or equals a. Now how to use the normal probability table? Suppose I want to calculate phi of 1.55. One method I have already told you, that is you can go for direct integration. The other method is using the normal table. Now how to use the normal table? Suppose we want to find phi of 1.55 from the normal table. What we should do? We move vertically down along the column of Z to reach 1.5 and then move horizontally along this line to 0.05 to intersect with the numerical figure 0.4394. Hence, phi of 1.55 equals 0.4394. I will tell you this. See, this is how a normal probability table looks. Now suppose I want to find probability of 0.32. So what I should do? First I should go for 0.3 vertically, then 0.02 horizontally. So now I have come to 0.322. So this is probability of 0.32. How much is it? 0.1258. One more example. Suppose I want to find probability of 1.53. So what I should do? Vertically, I should go for 1.5, 1.5 and 3 is there. So 0.03 I should go. 0.03 is your fourth column. So 1.5, here 0.03. This is column for 0.03. So 1.53 intersects value is 0.4370. So therefore phi of 1.53 is 0.4370. So this is how we read the table. Now evaluate the following, look at some questions. Evaluate the following probabilities with the help of normal probability table. Probability of Z greater than or equals 0.85. We have already seen our basic formula. Probability of Z greater than or equals A or Z1 is 0.5 minus phi of A. Here our A is 0.85. So equals 0.5 minus 0.3023. This is the value for phi of 0.85. How to see phi of 0.85? Come to 0.8 here, 0.8 and 5. This is 0.05. So value is 0.3023. So that value has been taken. And this gives you 0.1977. Probability of Z less than or equals minus 2.43. We know that probability of Z less than or equals minus A is same as writing probability of Z greater than or equals A. So probability of Z greater than or equals to 2.43. So like the same question, 0.5 minus phi of 2.43. So answer finally is 0.0075. Probability of absolute value of Z less than or equals 1.94. From our basic formulas equals 2 phi of A. So 1.94, which is 0.4738. So 2 into 0.4738 gives us 0.9476. Next question. Probability of Z lying between minus 1.64 to 0.88. So this can be written as probability of 0.88, Z lying between 0.88 and 1.64. This can be understood as the area covering between 0.88 to 1.64. It can be understood as area covered up to 1.64 minus area covered up to 0.88 will give you the area covered in this range. So this is phi of 1.64 minus phi of 0.88, which gives us 0.1389. Let's look at one more question. If X is a normal variate with mean 30 and standard deviation 5, find the probability that X lies between 26 to 40 and X is greater than or equal to 45. Now we can see that this is a question of normal distribution. Mean mu is 30 and standard deviation is 5. So this is in terms of X. It needs to be, this is a normal variate. We need to convert it into standard normal variate, that is Z. So here mean is 30 and sigma standard deviation is 5. Now we need to calculate the probability for X lying between 26 and 40. We know that Z is X minus mu by sigma. So when X is 26, Z becomes 26 minus 30 by 5, which is minus 0.8. And when X is 40, Z is 40 minus 30 by 5, which is 2. So instead of solving probability of X lying between 26 and 40, we will say probability of Z lying between minus 0.8 to 2. So we can write this as minus 0.8 to 0 and 0 to 2. We know that minus A to 0 is same as writing 0 to A. And this is phi of 0.8 and this is phi of 2. From the table, phi of 0.8 is 0.2881 and phi of 2 is 0.4772. So hence the answer is 0.7653. Now probability of x greater than or equals 4, 5 is same as saying probability of z greater than or equals 3, because we need to convert this x into standard normal variate. This is normal variate, z is standard normal variate. According to the formula, x minus mu by sigma, so z is 3. Now probability of z greater than or equals a is same as 0.5 minus probability of z less than or equals 3. We have seen this. So this is 0.5 minus 5 of 3. So which is 0.5 minus 4.987, which is 0.0013.